Oh, hello. Okay. Great. Okay. Welcome. Good evening. My name is Kimberly Blackrincan. I'm the director here at the ignITe Hub. I'd like to welcome all of you that are here in person at the Hub for this event, and also all of you that are with us virtually. Welcome. A little bit about the ignITe Hub. We're brand new. We are 9 months old. Soon we'll be having our first birthday party, 1-year anniversary. The Hub is Montgomery County's newest innovation center here in the county. It's a collaboration with Montgomery County Public Schools, Montgomery College, the Montgomery County Economic Development Council, and the county government who funded us, and Apple. So this is an Apple-equipped lab. We have 30 MacBooks, 30 iPads, and you can see we have the collaboration tables. That's what makes us unique for hands-on project-based learning. A little bit more about the Hub. We are sponsored by Verizon for our speaker series. So for those of you in person that had dinner, we can thank Verizon for their generosity. Thank you for sponsoring these important types of series that we have here. Now, tonight is a little different because we have a VR showcase. So the event actually was most of the day. We started at 3 o'clock and we are ending with a talk. So we had some hands-on experience with VR. From what I hear, the comments were amazing. We've had some first-time users of VR. And so I'm very happy that the Hub was able to provide that kind of opportunity for you. So after dinner, here we are for our presentation. I'd like to introduce to you our speaker and also our facilitator for the hands-on experience earlier, Mr. Neil Levin. He is the founder and CEO of VR Training, and for the last 10 years and more, he has been focused on building innovative products and applications, initially in publishing and then simulation, AI, and VR applications for the defense industry. His most recent project was the design and construction of a B-52 mixed reality flight simulator to train pilots in midair refueling. Prior to his recent time in technology, he was a senior executive in the book industry. He was the publisher of Time Life Books and then the senior VP of National Book Network, the largest independent book distributor in the United States. In his last position in publishing, he was VP Strategic Partnerships at the eBook subscription startup Librify. So thank you. Let's welcome Neil. He has a great presentation. Thank you, Neil, for coming. All right, I'm going to pass the mic to you, and we'll go from there.
Thank you. Glad to be here. Well, thank you all for coming this evening. Very excited to be here. As Kimberly said, I am the producer and director. I am a producer and director. That's one of the titles you could use for me in what I do for training applications. I'm also, considering it's a small company, I'm in charge of business development and project management. I'm an integrator, solution architect, and a builder of teams. Tonight, we're going to have a full agenda. We're going to go through a number of different things. And before we start even going through this whole list of things, I want to take a second to talk about my favorite subject, which is, oh, look at that, which is the Moore's Law. Moore's Law, once I learned about Moore's Law, I understood why everything moves so fast. It's really interesting. It's the observation that the number of transistors in an integrated circuit are going to double every 2 years. And when you look at this chart here of in the 70s, we had 1,000 transistors on a circuit, and now you've got 100 billion. And actually, I saw yesterday that Apple's iPhone 15 has 15 billion transistors on one of its chips. That is truly amazing, and that is why it moves so fast. I ran into somebody at a conference not long ago who told me that they had the algorithms for AI back in 1970. They just didn't have the power to run them. Second thing I want to talk about is Ray Kurzweil, who is an American scientist. He works for Google as one of the chief scientists. And this chart of the exponential growth of technology really is wild. And I think it's why we all sort of say, oh my God, it's moving so fast. And this is really what's happening. And so since it's moving up that chart so fast, you can understand why everything surprises us every day. All right, so I'm going to have a very brief history of VR and just sort of try to get us to the current time, mostly the last 20 years, but let's go back, way back. A long time ago, painters tried to replicate what the human eye saw. They tried to stretch out and have panoramas of pictures and events so that people could see them really how they felt that they were. Moving forward quite a bit here to some of the earlier devices to try to get a stereoscopic view of really what's going on in the world. And of course, I like the ViewMaster, which today actually has a Google Cardboard type of ViewMaster, and it's still out there today. Moving forward a little bit, 1929, the Link trainer. I thought it was a term about how it worked, but it really was Edward Link, who invented it, and it was the first example of a commercial flight trainer, which was actually used by the military. And over 10,000 of these blue box trainers were bought. Cinematographer Morton Hellig created the Sensorama, the first VR machine, patented in 1962, which really wasn't that long ago. Full color 3D video, audio, vibration, smell, and atmospheric effects. This one I loved was called the Sword of Damocles because it hung from the ceiling and it really wasn't getting anywhere. But it was the first head-mounted display that actually had wireframes in there in 3D, and it also was one of the first ones to keep track of where your head position is, and that's a really important part of virtual reality. And then there's this one, which I just love the look of it. It's just so wild. This is called the Super Cockpit. Tom Furness, generally acknowledged as one of the VR pioneers. It led to all the form factors that we consider today in VR. And when you look at how he scoped it out, where it was going to go, you could tell that this was really on the track. And this is in the 80s. So once again, not too long ago. 85, VPL Research, best known for haptic gloves in the early phases, and also had some early headsets. But here is when it really started to happen. In 2010, Google introduced the stereoscopic 3D Street View, and Palmer Luckey started building VR headsets at 17, and his sixth iteration was the first prototype of the Oculus Rift headset. It launched in 12. It had a Kickstarter campaign. I think they raised like $2 million, and it featured a 90-degree field of vision, which was incredibly wide for the time. And then he sold it to Facebook in 2014 for $2 billion, and they say it really might have been $3 billion. And I think I saw his age today is like 30 at this point. He's going on to start Anduril, which is a defense startup valued at $9 billion at this point. The second thing I thought was really interesting in the growth of VR was Google Cardboard. I remember getting this in the mail with my New York Times, and it came out in 2014, was the original Google Cardboard. And I think everybody had their hands on one of these at some time or another. They're still out there today. The plans are out there if you want to build one yourself. And it was incredibly effective just to be able to get stereoscopic 3D, 360 photography was in there. Today, this is from, when did this start? 94, but you're going to see there's a steady stream of VR headsets. The ones in red are ones I've kind of worked with over the years. There's lots of them here, and we get more. They keep going. This was actually in 2021, and I know already there's a lineup of more headsets coming out. Speaking of two in particular, this is the Vario XR3. It's a $6,000 mixed reality headset, and we're going to talk about it later because I used it last summer on my B-52 simulator. And the Vive XR Elite, which is really a great step forward. It's much lighter. It's got the 110-degree field of vision, and the battery is located in the back. And anybody that had the headsets on today know they're very front heavy. And so this was really great to make it more comfortable. And this design we're starting to see more of It's mixed reality as well. And we're going to talk in a second about the technology associated with all of these devices. Actually, we're going to talk right now about it. We're going to get there in a minute, I promise you. So a quick walkthrough of what the technologies are, the basic technologies. And we're going to add one more. We're going to talk about 360 photography as well. Virtual reality, you are immersed completely in an environment there. The only thing you're seeing is what's going to be on the lenses. Augmented reality, we all have augmented reality on our phones. You can have Google Street View, you can have Google walking directions. What you're doing is you're putting another layer of information on top of an existing view of the real world. And it could be augmented reality glasses, headsets, or phones and tablets. And the last one is mixed reality. Mixed reality is where you're doing both. You're looking at a virtual environment, but you're also seeing real objects inside of it. And we're going to be showing you something about that pretty quickly. And my project last year was a mixed reality simulator. And we're going to talk about that a little bit more. Now, let's start with photography, the 360 photography. I'm sure everybody's run into a picture like this at some point or another. Imagine a circle around you, and you're taking all those pictures around you. If you've got a 360 degree, this is a 360 image that's laid flat. And so really the only way you want to be looking at this is in some sort of VR kind of situation. Couple different ways you can make those images. One, you can have a smallish object sitting on a platter. One camera is stationary. You rotate the platter. Wonderful. You're getting all these different pictures of your cat. Or you can have a rig like this. This is maybe 100 cameras that fire simultaneously, and they will get you that 360 degree image of somebody that might be standing there in the middle. There's another way to do it where you're in the center of something and you're using multiple lenses to record 360 degrees. I think they might show a little bit of that on the app of all the ranges of the pictures that are there. But, you know, in each of these situations, you've taken a single picture, and then the issue is, what do you do with them? You stitch them together. There's a lot of software out there right now that will match up the images and make you a continuous image. And that would be how most 360 photography is taken right now. You're doing that. I mean, we have panoramic views in our phones, but it's really not the same kind of thing as an image like this. Now that we talked about the 360, let's talk a little bit about content. Since we started there, there's another way to build content besides the photography, and that would be modeling. We have images like this, which are what we would call a low poly, and it's a low polygon image. So there's a lot of flat surfaces. There's not a lot of little surfaces. Those kinds of images render quicker. And you can either make them, there is a career in 3D modeling. There is a career in 3D modeling where you're creating models in various situations. And it's a lot of situations or applications where you're creating a new environment would be one where you would see modeling to come to the fore. Another way is actually you can buy 3D models online. This is TurboSquid, one of many, many sites that have 3D models. And the models come in, different kinds of intensity, low polygon, high polygon. They'll have rigging where they can move and you can control their movements. So there's lots of different ways to get content into these kinds of applications. But I wanted to spend a second or two talking about digital twins. We hear a lot about digital twins, and they range from the simple ones with only exterior skins. So if we had a box that just had, images, the 360 model of the box, there's no action to it. It just is that box. And it ranges all up to number 5, excuse me, which would be an autonomous twin. Let's say you have an engine which digitally is rendered to be an exact duplicate, and its behavior is exactly like the original engine. It runs on its own. We're going to talk about digital twins. Actually, we're going to talk about digital twins now because there's a project that we've been involved with a little over the last few months. that has we've put out, we responded to a request for information, and it's about a digital twin for the UK. And there's a little video that I'm going to show here, which explains this project that's going on in Germany to build a digital twin of their entire rail network.
Schiene Deutschland, or DSD, part of German railway network Deutsche Bahn, is designing and building a digital twin of its rail network to maximize transport efficiency and capacity without building new tracks. Realizing a digital twin of 5,700 stations and 33,000 kilometers of railways is a massive undertaking, requiring a custom 3D pipeline connecting DSD's HD map with CAD datasets and simulation tools, including those from Siemens JT ecosystem. In NVIDIA Omniverse, based on Open 3D Framework Universal Scene Description, the teams are able to connect and aggregate critical data sources into a single high-fidelity model. With a single source of truth, DSD can use the digital twin to test and validate the entire network, enabling continuous improvement in the deployment of vehicles and railways, maximizing operational efficiency and speed while reducing costs. Beyond simulation, the digital twin will provide the environment to train the complex AI that manages the fully automated railway system. Running on NVIDIA OVX, the digital twin can be synchronized to the real-world trains and rail networks via 5G-enabled sensors and 5G edge microcells. If a train's cameras or LiDAR sensors detect a potential hazard, its precise location can be quickly relayed to the rest of the trains in the network, preventing a collision or congestion. If the AI-powered computer vision-enabled cameras at a station notice an issue, an event can be triggered to instantly notify personnel. The intelligent sensors are trained and optimized on a combination of real-world and synthetic data generated by Omniverse Replicator, ensuring the models can perceive, plan, and act when faced with any scenario. With Omniverse AI-enabled digital twins, Deutsche Bahn is working to increase efficiency and capacity of the existing rail networks, reducing waste and carbon footprint, while keeping passengers and goods on time.
The RFI that we just responded to was for building a digital twin of the UK railroads to train their drivers. They wanted to drop their driver training from 15 months to 8 months and use the savings to build a project like this out. And we're going to talk a little bit about the camera that we're doing this with. Excuse me. Well, let's jump over to VR for a minute. I love these images. They crack me up. So this is supposed to be what you're looking at inside the VR headset, all these like things going around there. Or this one, which is even better. This is, I'm reading my, looking at 17 charts all at once inside VR. Eugenia, I don't think you saw this today in your VR. No, that wasn't there at all. In a lot of ways, VR is a pretty simple operation. I say that sarcastically. It's like a little movie camera almost. You are looking at TV in it. You can get your Netflix app for it. You can watch, your movies on your headset if you'd like. But there's much, much more to this, of course. But in a lot of ways, the basic visual side of it is that. But what's important is if it was just a picture in front of you, it really wouldn't replicate VR. Because if I'm looking at something in VR here and I turn my head this way, well, that picture is going to go with me this whole way. So it's really all about pose. Pose is the position that we're in that is one of the most important parts of VR. We have to know where we are in space. Because if it's not accurate, you're not going to see that virtual reality environment. It's not going to act the way you expect it to as a real life. SLAM, simultaneous localization and mapping, is a basic part of what we do. Now, determining your position in space is the challenge. How do you do that? There's two different main ways. And it's all done with tracking. So it's either tracking by outside monitors, and let's say we had a base station, they're called base stations there and there, it would know where I am, it would know where my headset was, it would know where my controllers is. Or the other thing is to have inside out tracking where your headset actually can show you where you are in the space. Here's another view of the outside in tracking. Base stations go on the wall, and 5 years ago, this is what we all did with a wired computer. Now we saw, and oh, here's another picture of what it would look like in a room on these pedestals. We would have them all over. And in certain situations, you still do this, but it's not the optimum way to go, and it certainly is the most convenient. On the Oculus Quest, anybody who saw it today, and we've got one here someplace, is that there's 4 cameras scattered around the headset. They can track where you are, and they can track the position of the controllers at the same time. So somebody asked me today, why can't they see where my feet are? Well, there's no camera going down there. There's no tracking going down there. So that's not going to happen. We're all going to be legless for a while, I think. Maybe not. Okay, let's move over to augmented reality. Augmented reality is, as I said, you're putting an augmented layer of information on top of a real life object, on top of your view. It works really great for industrial environments where you are trying to fix something, where you use computer vision to identify the shape of an object, and then you already know what that object's points are that you want to identify and look at, and you have that here. Another one would be to look at a warehouse where you're able to do a pick pack operation, go to certain areas, keep track of inventory. And so you could have information from your inventory going into your pad at the same time. And so it becomes an interactive environment, an interactive way to deal with a warehouse, let's say, connecting into your ERP and your inventory system all at once. And then we have a mixed reality, kind of augmented reality, mixed reality, where you're doing something which is great from a retail and consumer standpoint, where you're taking a real 3D model of something that has texture, it has size. You've done a scan of the room to know the dimensions. You know, you've done a mesh of the room. And so when you put this couch there, it is going to be true to size for the space that you're in. Lots of retailers are doing this now, which is a very smart thing to do. I'm going to cheat a little bit here and talk a little bit about mixed reality in something that we built last summer. This is an image of our B-52 simulator. It has a real yoke, the steering wheel. It has a real throttle and a real B-52 seat. When I say real, you can't get parts for a B-52. They don't exist. They're a 70-year-old plane. There are no spares. We had to make these one-off copies of these things that I will not tell you how much they cost, but it was a nice car. They all operational too. The throttle had 8 moving levers. There's 8 engines on the B-52. They all had sensors associated with them that you know where they are in space. And when the pilot is in the plane, they see real hands, a real yoke, and a real throttle in a virtual environment. And this is essential for really building muscle memory, which is what we did last summer. Is you're trying to teach somebody to do something. They can't have, we call them alien hands, drawings of where your hands would be. It's not going to make your mind remember what the action is. Content, you have content. We've talked about where content comes from. We've talked about the different technologies. They all come together in a game engine. In this particular case, we're going to talk about 2 of them. Unity. Unity is the most popular one. It's the Chevrolet of game development. It can cover anything you need to do. You can put active applications inside of it. You can go high end. You can get complicated things inside there, and it's hard to do. This is a Unity development screen. Every piece of that illustration has to be controlled. It's motion, it's perspective, it's lighting, it's shading. Unity is great to learn. It's a great career. And on Unity alone, you can find jobs. There are spots for Unity developers everywhere. The other major game engine is Unreal Engine. Unreal Engine is more high end. Unreal Engine is in movies. When you see an avatar that looks like that, that is amazing. That is lifelike. And this is what you see with Unreal, and all the major movies are going to have that going as their engines. Other images like this. And the other day we're working on another project on amphibious vehicles, and so we were looking for somebody who could do some coding and development work in that could help us in the project. And he wasn't interested. He's not really in that direction, but he sent us this video. which shows Unreal and how Unreal works in water. This is an Unreal engine, Unreal imagery. That's amazing. It really is. So now I'm going to make a break and talk a little bit about my past performance. It's scrunched it up there. Don't like that. It's amazing how fast the technology is. And actually, this image is another image of another type of my simulator for a different situation. But in 2017, I was a partner in a company down in Bethesda, and I was the CTO there as well. And we had a contract to work with the United States Postal Service. We were digitizing some of their print work and building, basically digitizing their print process, databasing all their content, building applications. And they said, can you build virtual reality to demonstrate, to show off new series of stamps? And we said, sure, of course. We never did it, but fine. And so we started building out some of these virtual reality experiences for the United States Postal Services. Can you fire that up? A gallery of stamps. These are the books we had created. Throw them off. This is going to lead into a proof of concept that we did for the Navy. So I was so what happened for me was that I was pitching virtual reality to a museum in Norfolk, Virginia, and they had a Iowa class destroyer next to their museum. And we did a tour inside of it, and there were no signals, no GPS, no cell signals. You couldn't find what we were doing. So navigation inside was crazy. And I was like, I'd love to have AR down here. I'd love to have augmented reality to direct me to do things. And they had some hokey display of what an engineer was doing down at the bottom of the engine room. And I thought, we really need to find a better way to do this, which got me on a path to virtual reality, to working with the government, because I found a gentleman over in Austria who was doing inside navigation with persistent augmented reality, which meant it was augmented reality was locked to a situation. And he was trying to get into the Navy, so we worked together to do this particular project, which was to provide engineers coming onto a ship for the first time a way to navigate to where they had to go, and then provide persistent augmented reality there for them to learn about the items that they were trying to work on. Fire back up. That's persistent AR locked into that screen. So I presented this information to at Augmented World Expo, which is the largest augmented reality conference in the country. And I finished my speech, my part of the talk, and I was approached by a chief technology officer at Keesler Air Force Base in where was it? It was someplace in the South. I can't remember right now. It's far. And so they got me into some of the programs in the Air Force. Air Force was trying to bring in small businesses to try to accelerate the innovation process. And they were great to work with. It was very fast to go from beginning to prototyping. And, and it was really kind of all associated with the SBIR fund. Does anybody know about the SBIR fund? Okay, this is like one of the greatest things in the world. The SBIR fund, every major branch of the government has to put in 3.2% of their R&D budget into the SBIR fund. In 2023, the SBIR fund is $3 billion. The DoD has a major chunk of that, I think 1.9 billion. But every Department of Health, NIH, NSF, Department of Education, they all have SBIRs. They run 3 times a year. They usually start off with a phase 1, which is basically tell us what you're going to do and a plan. They might be $50,000 to $100,000 on phase 1s, and phase 2s usually are $750,000 and more. And the goal is to build a prototype. All these parts of the government love this because they're not using their own R&D money. They're using the SBIR fund. And so it's an amazing program. It's different in each branch, but for the military, it's huge because their budget is already pegged and they can't really go out of their budget. And it gives them an opportunity to bring in small companies. Small companies move fast. They're less expensive than the bigs. They're easier to work with, and they want to get involved in this. And so it's really an amazing part of it. That started me on my path of going and started to work with the DoD. Yeah. I'm sorry?
What is SBIR stand?
SBI, Small Business Innovation Research. Okay. And so it's really about, these technology companies that have a new idea and they want to, the SBIR fund in certain situations, they really want you to be a commercial company, bringing that tech into that branch of the government. But that can be loose. Sometimes they just want your tech. And back in 19, when we started with it, we pitched one thing and they wanted to do something else. It was like, okay, we'll do it a different way. And we were accepted into the phase 1 and phase 2 in a matter of days. And the first project that we did with them was a network training next. What it was to train data center technicians in how to do their job, how to build logical networks. So if you could run that, this is a commercial. In those days, they want us to make a commercial for what we intended to do.
The 338th Training Squadron trains the entire population of cyber transport technicians in the Air Force. Proficiency is tested in a capstone lab where students configure an entire suite of actual network equipment, which can take up to 3 days per student. A skills gap currently exists in the transition from training on software simulations to working on actual equipment. Introducing a virtual network environment where students train on virtual equipment will close the skills gap and speed up the training process. Working in virtual reality, Network Training Next becomes scalable, where multiple students can train at one time, moving across an airbase from network center to various comm rooms, increasing trainee throughput exponentially. With 1,100 annual students projected by 2022, this increase in capacity is critical. Students can train at any place and at any time, increasing trainability and improving performance. This very early concept of Network Training Next shows a student working in virtual reality inside a comm closet with a laptop, a rack with patch cables connected to ports, a server, and a network diagram. The student connects a virtual laptop to a virtual port, and various port connections appear on screen. The student moves to make the virtual connections with patch cables, and the network configurations appear on the discovery board. Similar to the success of Pilot Next, virtual reality training promises enormous benefit to the Air Force and beyond, to the Navy, the Army, civilian big data companies, and colleges and universities.
That was great. I love that. We didn't make it that. That's what we made. What we did was we had to, one of the problems in dealing with the DoD is that there's a lot of changeover constantly in who's running your project, who your customer is, who your user is, and who your buyer is. But this is what we ultimately built. They got rid of the cables, and we really did it more by actually just going through a computer system. Is that one there? No, it's not there. Interesting. See if it's here. Well, have it here. Did you click on the center of the image? Yep. There we go. So just going to sort of talk through this one. We had to have, of course, some information on how to get into the system. And you would go, and what you would do is you would land in the main communications room in the 338 in Biloxi at Keesler. And this is all models. This is all hand models of what this space was. And anything over 5 feet, you would transport somebody. You didn't want to get involved with moving too much in the virtual space because it gets challenging. And it's also very hard to type inside of virtual reality. So what we would do is we would use the pointer a lot, and we would give them choices on what to do. And you would be able to dive into the network and basically build a virtual network. Unfortunately, it's one of these kinds of projects which it got lost in the transition between its TPOC, its technical point of contact. They changed over and they changed what the process was. And they also changed what the schooling was and the course load was. So in this case, you couldn't leave the room. If you wanted to travel, you had to take your laptop with you. And this would give you the ability to travel to these different locations on the base, Nellis base. And then you would go and put your laptop back in there. This is just another little thing we had in here to explain all the different devices that were there. You would point to them and see them. And this is really much more of a practical use of virtual reality for training. You're replicating the ability to travel to these different locations. They had one lab, and you would go to each different corner that represented the different comm groups you would go to. And so, okay, we can go to the next one. So these were all part of AFWorks. AFWorks was that innovation hub that they had for the Air Force to move things along rapidly. It was able to move it rapidly. You had a cohort of people that would go through with you. And they also had these challenges, which were a little different than the SIBR. They would be something where you were told about a problem, something like the mixed reality refueling challenge. You were told about this problem. You were told what they were trying to solve. You were given some wide latitude on how you solve the problem. For this particular challenge, there were 103 companies that applied. And you can see the timeline was really from March 16th to August 10th, a year and a half. So we did this, and we got our contract. We were one of 103. We had the down select, what they call the down select, which is they went from 103 to 25. And then went from 25 to 5. We signed our contract on December 8th, 2021, and we delivered a finished simulator on August 7th in 2022. We didn't start building it until actually February 2nd. So in 6 months, you'll see what we built. Let's go to the next one. And so what I did was, if you click on the around the yellow, there should be or next to it, there should be a bar for the video. No, underneath it and to the right. Just go to the right a little bit. No, sorry, not that far. Just a little bit past the yellow bar. Oh, there you go. You had it. So what I did was I just put the slides together of really how we progressed. But this is what it looks like for midair refueling for a B-52. When the two planes are together, our first concept was to build a backlit screen for green screen. Green screen would give us high fidelity. Our first iteration was that. Then we moved to these curtain rods almost of perfecting the green screen and using just stand-ins for the throttle. Our first design, we kind of knew a little bit more where we're going. We were still this is March, and we're still working on our design of what we were going to do. We had an engineering company that we subbed out to for building a lot of the pieces, continuing to move through the process. We're getting further in the iteration. Now we knew what our green screen was going to be shaped like. We have a motion platform. We're still working on trying to backlit the green screen, but we ultimately found there were too many shadows in it, so we couldn't do it that way. This is the hardware associated with building this thing. This is still like maybe May. A little bit more understanding about how the green screen was going to be constructed. And then there's a video here for this one as well. Actually, there it is for the next one. And there's a walk around in maybe June while we're actually putting it together. The plastic of the green screen was custom built for us, custom designed. That's the throttle we had built for us. We ran into a series of problems, frayed cables, heating problems. We solved every one really in a day, and we were able to close it all up. This is it with the skin on the outside. Stelic is the name of my LLC. And this is one of the pilots coming in here. This is a video as well. This is one of the pilots coming in there to tune the system to make sure that we had really the feelings. We were using force feedback. And this is actually a longer video of the pilot inside actually flying it from, this is the headset view. You can see the real elements there. And this is the beginning of the software. We didn't write the software, but we had to integrate in 5 different components into our package to make it all work with the software. Because the steering wheel gave the pilot the impression of flight, and this pilot's behavior went into the software to steer the plane. So it was called force feedback. We used a whole new type of engineering, electromagnetic motors inside of this thing. And that was revolutionary, and the green screen as well. And actually, I have 3 patent applications for this right now for the design. And you can see that this is an early one. The green numbers were just a cheat code during testing, and it was still early. The flickering that's going on there went away in the final. The pilots have to line up the plane, the tanker, in their windows, and everything had to be exact. We delivered it, and this is us at the the Cyber Innovation Center before the 24 pilots came in to test it. And then there's going to be a video, I think, of the, oh, it's part of it there. This is the actual process of the pilots came in pairs of 2. One would be instructor and observer. And you can see the software is so powerful, shows multiple views of the process going on. The pilot's view is on the right, but these other views help the observer see what's going on. You get a better picture of the pilot in the simulator. And this similar concept is really very different. The quality and the fidelity of what the pilots are seeing because of the green screen and the lighting that we did. There's a motion platform in this as well. And the more experienced the pilot, the less they wanted motion, is what we found. It's currently being used at Barksdale Air Force Base in Shreveport, and the B-52's pilots are using it now today. And the next video is going to be in the next screen when this is over, is going to be the pilots' testimonials about using it. That was us at the end. And that was me in front of a B-52. Buff. Amazing. So the next screen, oops, there we go. This was made by the StrikeWorks team. Oh, and one more. Yeah, there you go. So they had it in Shreveport. They had members of the Air Force Research Laboratory there, other divisions, other units. The software developers are over there in the middle. Some of my contractors are there with me as well.
Overall experience is I wish we had that, when I was coming up, having something that I can go sit behind and kind of play around with and figure out my tendencies and kind of how the aircraft might react, especially with another aircraft in front of me on the ground where it's safe, would be great. In the VR training that we have here, really, you get a chance to kind of set the conditions so I can build good habits correctly now on the ground.
What they have right now is the closest thing that we can get. It'll be great for the 11th Bomb Squadron to have initial qual, seeing how to actually fly before getting into the jet and being able to learn tips and techniques, saving money in the long run for training overall.
I think these simulators are a great tool. I just finished my initial qual training, so I definitely wish I had this because AR is one of the hardest challenges for the new pilots coming into the B-52. Having the ability to practice and train in that simulated environment where conditions are stable and I'm able to focus on what I'm doing to influence that is really, really helpful. Sometimes it's even little things like getting used to the indicator lights. When you're a first-time student kind of going up there, sometimes you get yourself backwards and you do the opposite of what you should have done. And And a lot of those little brain tweaks can be worked out in the VR sim.
It's definitely a great experience today. Very impressive to see the technology that's been presented to us today. Air refueling is definitely a challenge for us. This just provides another tool for us to actually train to the things that we actually do. I see myself, if this comes to our squadron or to the FTU, I see myself using it more often than not.
Well, I've heard it and I can see it now that air refueling is really difficult. These sims are available during our FTU, then I'll definitely be using them.
FTU is the formal training unit. Vario, the headset manufacturer, loved the story so much that in November, we did an hour webinar, international webinar with some of my contractors, explaining really from beginning to end how that process went completely. I really enjoy working with the DoD. I find that it's really interesting, and I have done. When I looked at this list, I was like really wild how many things I've done now in close to 4 years. And I cover a lot of different things. I work with San Diego State University. I work with George Mason University. There's companions to the SBIR program called the STTR, which is where you work with universities, and they have a greater piece of the pie, and they put a lot of people into it. And a lot of these challenges, which I like them a lot, and 1 and 2 are the ones we're working on right now and seeing how they can progress, hopefully. And this next one, is just the camera that we're talking about using for the digital twin of the railroad is $600,000 Leica camera that does basically a humongous point cloud everywhere it goes, because it takes the slice, I think, every like 3 centimeters or even less as you go forward to build a point cloud. And a video camera is in there as well to marry up the point cloud with the video. Moving forward, I want to do a little sidetrack here and talk about careers in XR. It is more than game engines. And I was talking to somebody about this, about careers. Who were we talking about careers? Some people come out of college or they're in college and they have we were talking about it. They have a career, they study for something, they have a career, they do that after college, and that's where they are forever. My career looked like that. My career went all over, but a lot of people do that. And even with the gig economy, it's even going to be more and more, I think, where you're in some cases you are, but in a lot of cases you're going to have a career like that. I actually, when I got out of college, I worked on that computer right there, a Data General Nova 3, and it's a 5 megabyte hard drive. That thing, the size of a trash can lid. And I wrote a software application that got me into publishing, and I did that for 25 years. But in 2009, I got back into working in tech, and the first thing was to do something for publishing, and I built a little site to give small publishers exposure. And then after that, I went to work with a startup for books, social platform around ebooks. Love startups. Love working in the startup world. It's a great place to be. But enough about me. The point is to follow your curiosity and your passion going forward. Yes, you do need to know about game engines, but in my 6-7 years of doing what I'm doing, I found that I've had to learn all these different things to be able to speak to my developers. And beyond that, every time I look at that list, I realize, oh, I also need to know about top secret security clearances. And we actually had a project where we were talking about using, what was it? Librify. You can use fluorescent lighting right now to send Wi-Fi signals. And it's called Librify, and it's far more secure because it doesn't bleed out of the space. And there's a couple purveyors of it, and in the Army spent like $20 million to use it in Europe. It's called Librify. It's wild because it blinks at such speed you can't see it. Okay, so you have to learn about that stuff. Who knew? And of course, AI is just so much of what we do right now. A lot of engineering I picked up while building the simulator. And going forward, we're going to start getting into some of the things I think will be happening down the road here. Voice and gesture are going to be how we control our devices. We see that some of it now. It's going to become even more popular. And so, I think it's very important that we If you're doing voice to text, you know that it's very important to think about what you're saying before you say it. It's, that way you're going to get the right answers, what you want. But let's talk a little bit about where this is all going. Apple headset. Okay. Long rumored, 7 years in the making, 15 cameras. These are artist renditions. 15 cameras. That's where your feet are going to come back. Okay. They're going to have one going this way. Eye tracking is going to be built in. And, it's mixed reality is what everything is right nowadays, is what we're doing. So I don't even know what the other 12 cameras or 10 cameras are going to do at this point. So I'm certainly looking forward to that. I believe that this headset, even though it's going to be expensive, could still represent another sea change in where we're going. Similar to Palmer Luckey and the Oculus Rift, similar to what the Google Cardboard did. I think that this can be one of those to bring higher quality, lighter headsets more into the consumer marketplace. Another company that I follow is Mojo. Mojo has built a contact lens that has basically it's an AR device in a contact lens. They, unfortunately, because of the market downturn, they've also done a little pivot right now to sell high fidelity small displays, considering that's what they made here. But it was tested. It was at CES last year, and somebody put in their eye and they tested it. It is working. It's really a wild little thing here. It's a tiny little thing, and you can do it. And there's another company that I follow, which is another interesting approach, which is iJet. They're developing a system that can project all kinds of digital information, including images and video and augmented reality, directly into your eye. So it's a different approach. Instead of looking at something, it's going right into your eye. Yes.
We haven't got a chance to
play with that yet.
Yeah.
I'm connected to them. I keep talking to them. A lot of the Israeli companies right now, they know that they have other ways to get into the States, and I can't rep them into the DoD, but I follow them for that reason. So going forward, yeah.
How can this help folks who are for the blind?
Well, these kinds of this kind of technology is great because what they're talking about is building corrective lenses into the image you get right into your eye. So whatever your problem is, it's going to adjust in what's projected right in there, and you don't need corrective lenses. And actually, it's one of the things they talk about for the Apple glasses, the Apple headset, is that it's going to have automatic. Actually, you're going to be able to have corrective lenses put in according to your specs inside the headset. So, I think it's a valid thing. And for me, I need corrective lenses, and I'd like somebody to put the right image right into my head. I don't mind that. I don't know how going forward, okay, I thought this headline was great because I think it's really one of the things that we're going to see. I think that the next smartphone will be our glasses. I think it will get to the point where the first few steps will be, we have AR glasses right now for industrial applications. They're not that great. The first ones are going to be connected via wire to your smartphone. Then they're going to be Bluetooth to your smartphone, and then they'll be wholly incorporated in the smartphone. And here's another one that goes a little bit deeper, talking it's a little bit tough to read, but everything is really going to be there in the smartphone. And I think that this will be the way to go. Yes.
I think that, correct me if I'm wrong, Google shut down its.
They did. Last couple of days, yeah. Yeah, they announced that they were going to shut down. I didn't realize they still had the enterprise version of Google Glass, but yes, they did shut it down.
So is it like the next version of that?
No, the Google Glass was really just like a very small monitor on the end here. The industrial glasses that we're seeing right now will have sort of a higher display on the top half of the lens. And they look pretty good. nReal is one of the companies that has a lot of them. And it is getting standard, and Moore's Law will help us get those things more incorporated. There is a glass cure company out of the West Coast I follow. And there's another company in Canada that I can't remember, but there's a few of them moving forward. I love Free Guy. So Free Guy, I don't know if anybody's seen it, but I'm sorry, go back to that. Yeah. So he goes to the point and he puts on the glasses, and this is what he's actually seeing. And I think it's going to be more of that. I don't think it's going to be, well, we're going to get to the M word in a second. Moving forward. This one I saw the other day, which is really important. We do a lot of we're trying to do a lot of stuff in the DoD where we're taking 2D images and making them into 3D. We need them. They want to build digital twins, and how can you build a digital twin of a 50-year-old destroyer? And so one of the problems they run into is something like this. But of course, moving forward, this is happening already. Content is being developed by AI tools. I was on Reddit yesterday, and there is already a few people that are experimenting with using AI, something like Stable Diffusion, DALL-E, Blue Willow, to be able to describe what the exterior, like the room. I can tell you what the room will be in AI, and it's going to drop that imagery into Unity and move it forward. Moving to the next one, yes. Digital twins. Oops, here it is. Digital twins, AI generated content, the N word, and Ready Player One. Anybody see Ready Player One? Have anybody see Ready Player One? Yeah, okay. We talked a little bit about digital twins earlier. I think what's going to happen is we will have digital twins from a lot of spaces. There's 3 billion gamers. Any day you could have 3 million to 20 million people playing Fortnite. The gaming community is huge. Will everybody live in the gaming version of the M word? I don't really know, but yes. Excuse me?
I have no idea. What is digital twins?
Oh, digital twin. That was the video I showed of the train where you're building an exact duplicate of a space, even all the operating elements inside of it. Okay, so a digital twin, we could build a digital twin of this room. I have an app on my phone. I could do a mesh of this room right now and have a 360 image in like 15 minutes. What's Ready Player One? It's a movie. It's a movie. You should see the movie because it really does explain really what it's going to be like in a world where everybody's in their avatar in a shared space.
What is
Ready Player One, yeah.
what is M word?
Metaverse. They talk about the metaverse like we're all going to live there in one big space. It's not going to be that way. I mean, there will be enterprise corporate versions or in school and educational areas that, you'll go into school that way as your avatar maybe, but even now they have spaces where we can work on multiple people, half a dozen people can work on a model in the same space, talking to each other and communicating. And so that's going to be the kinds of space. We're not all going to live in one shared environment. That's not going to happen. Yes. Well, that's one of the things that happens is people don't really have a lot of great definitions for it. But it is really what they're describing is a shared digital space where everybody can inhabit themselves or as an avatar in a shared space where we're all together. So if this was a metaverse room, I could be sitting in Baltimore and an avatar of me would be here speaking to you, speaking to your avatar, and you could be wherever. No, that's a little different because that's a transportation item. That it's a little bit like that. It's a little bit like that, but your body's not there. In the transporter, you're going down there, and so your body's there. This would be a representation of you in a different space. And we're yeah. So I think that really covers. Yes.
Yeah, I was gonna say something, but I was gonna make a comment about digital twins.
Yeah. Mm-hmm.
It's a shopping app where if you want to get, for example, like appliance or like TVs, you can map out. You can use your phone as an augmented reality to like measure out and map out if it's going to fit in your space.
Right. Go back to. Sounds like you can go back to where was it? Missed it. Yeah, the couch. There's couch 48.
Yeah.
Right. So you see if it fits. You see if you like the colors. I think it clashes with that rug. Okay. So it's a different kind of thing. And let's go back to. Can we go back to slide 36? The digital twin. Digital twin. This is something that I hadn't really seen this before up until recently. There's now a structured level of twinning. You could just have a basic 3D model, but you also could have a 3D model that acts on its own. It acts on its own, a 3D model that actually, they're talking about making digital twins of the human body to try out drugs on the body that way. So you're replicating all the systems, how they behave and interact, and then trying out the drugs to see how they work on the body. So that's obviously tremendously beneficial for all of us. Well, you have a few things going on in that world. I actually know somebody that's part of a startup here that has a truck, I think, that can pull up to a disaster area and make drugs on the spot. And I think that I can't remember the gene editing. What's it called? There is gene editing now that's available for everybody. Yeah, I can't think of it. CRISPR, exactly. CRISPR is readily available now, and CRISPR is used for a lot of things. One, you could use it for a single drug or single change to the genetic structure of somebody and change their current body to, solve whatever their issue is. I was just actually going to go over to the second to last slide, 94, because we are at the end. Wow, only 1 minute late. Sorry, they got scrunched up there. Anybody who wants to reach out to me, you can get me at neil@vrtraining.io. You can certainly connect up with me on LinkedIn. It's my pleasure to help anybody out that wants to know more about space and Q&A. No, I'm done. What do you got?
What your thoughts are on how could this maybe be the future of like teams playing other teams from other countries without the difference in the person that was more or less like a team in Europe or Asia, but actually having to fly out there.
Right. Well, I think that'll happen. Certainly they're using it for training. Striver, the company STRIVR, was formed by a graduate student at Stanford, and it's what's used for football now. So they have lots of apps for how it all works. But when you get to the point where you're in a digital twin world and you have the characteristics, it's Madden, Madden 2037, but Madden 2037, I think you'll have it. I think you will. I mean, because the gaming is really ridiculous right now at this point. So Striver is a VR company that's set up for sports. And even the Quest, you can get, baseball training and things like that. Early stages, you need to build the characteristics of an individual player in, and then let AI run the games to see what happens. Yeah. Right.
How can I train with you? But they don't have the funds to fly out.
Right. Right.
And so like thought about like doing something on an iPad, like just like FaceTime.
Right.
Zoom type of call.
Right.
But most exact precise real time.
Yes. Well, you got the delays in transmission. There's actually for the Air Force, which I know about, there's a company called Red 6, and the visor now for the fighter pilots include augmented reality. So they're not really fighting against a red team, which would be a real competitor. They're actually fighting against augmented reality. And so once again, you're saving all that money. And it's really on the path of what you're talking about, because AI is really running some of those, the red team against them. Get a question?
So, okay, I'm not sure if it's possible. First reality.
Yes. Yeah.
So say it's like the girl wants to be perfect strong that you actually see.
You want a 3D print a strut? Is that what you said?
So you're looking at that. Like,
Yeah.
Walking around this.
Right.
And everything. You're looking at it. Is there any way, as step by step, as you're looking at it, as also 3D printing?
Well, well, yeah. I mean, CAD/CAM, so computer assisted design, is really where the files come from to do 3D printing. So if you're looking at a particular piece of, a particular part of a car, those CAD/CAM files exist already. Now, could you, they are printing metal 3D. It is working. I mean, one of my contacts at the Navy And in the Philly labs, they are printing 3D metal. They're still not there yet. I think it's something large, but that's what they're doing on boats now and ships when they're out at sea. They want to 3D print a lot of things. And so it will be there. You know, it'd be nice if we have plastisteel, but we don't have plastisteel yet. Not yet. Do you have a question? Are you good? Okay. Yeah.
For example, in the real estate industry.
Yes.
Is there a company that uses this technology to?
Yes, absolutely. Well, Matterport is something that's out there right now, and Matterport is a 3D of interior. But I've had situations where I've spoken to people about you are a real estate developer and you want to show what it's going to like to have the buildings that you're designing to sit in a plot, and you'd be able to hold this up and see on that block, this is what those homes are going to look like. You could also, I know that there's construction companies and remodelers who will show you what your kitchen looks like. You can do it either by having it on the pad or actually in virtual reality. You want it to be gray versus green, and you can do that, change the colors there. That exists. There's companies that do that now.
So if I want to buy, if I want to buy a house, instead of me going to the house, you know, somebody can take.
They already exist. Yeah, Matterport. Yeah, Matterport is for many, many houses now where you could be at a spot in the house and you can rotate your image to look all around you. So those exist already. Matterport is the name of the software for it. Yes.
I was wondering if you could address the haptic feedback.
Sure.
So
Sure.
like, for example, with the B70 simulator, one advantage was having the yoke and the actual instrument.
Right. Right.
Feel how hard.
Right.
But then, like, what, like, back to this example with, like, if you ever get to the point of simulating football in VR, like, how would I know how tightly I'm holding the football, how my fingers, you know, keep the football to throw the best shot, or even just like taking a hit.
Yeah.
Another player.
Yeah.
How do you think that would have been?
Well, haptics are still lagging behind. The haptics gloves, they're just crazy bulky. They really are. I mean, there's a lot of them, and there are some semi-haptic suits. Like there's a Tesla suit, I think it is. Not from Tesla. It's like they use that name. But there's no full body haptic suit yet. And it's going to be 10 years before they have one. When I did the B-52, on the list of probable solutions, they said haptics could be included. We really decided that the way that force feedback works on the simulators is it's providing you the feel of the plane through the yoke and the resistance of the wind and everything else and the weight. That was enough. We didn't want to go to haptics on it. And I've yet to see in all the events that I go to, I've yet to see haptics that I'd really like to have on my hands. And certainly there's no full body haptic. Yeah, well, it's so the motors that we use. Am I still on mic? Okay. The motors that we use, they provide force and they read force. So they work both ways. They're getting their information from the software about what the pilot's doing and the actual physics. We talk about physics a lot of the two planes. When the two planes are together, it actually changes their normal physical behavior, the physics behavior. So it provides force feedback and also reads your feedback. So you're not getting the haptics, but you are getting the haptics. You know, it's not the same kind of thing, but it's the approximation we did for it. Yes, you had a question? Yeah, sure. Great question. I actually had my first LLC. Oh, geez. I've had like 5 companies. I was either a partner or started on my own. The LLC that I use right now, I renamed the one I started in 2009 when I got back into technology for Everpub. That was the name of that company for small businesses. I've thought about that a lot, about what would have happened if I would have stayed in tech when I was doing it then. And my rule is you are where you are. You know, and there's no sense in, you know, I actually had that option when I was considering to go into publishing. I was offered a job from another company to be more in the early PC world, and I decided not to do that. And I have no regrets. And I wouldn't get to where I wouldn't get to here if I didn't do those things. So, and I'm having the best time. There you go. Yes.
Things that you can do for is like in an accident or basically having the car safe. Is there like a VR system
We have on the B-52 simulator, we have a motion platform underneath it. And so it's really only sits, when it's down to the floor, it's this, but when it comes up to its regular height, it's about this high. And it does 3 degrees of freedom. So it does front and back, sideways, and up and down. And so that also feeds its operation is fed into from the software. So when you turn your plane, you turn. Now there's simpler ways to do it. You actually can even have almost like bass speakers in your seat to make your seat act like, and give you, I don't know, like even in Orlando, I think in some of the stuff at Disney or whatever, your seat vibrates. The amphibious simulator that we're talking about now, they want it very low price. So they want it to be something that where it literally goes in what's called a Pelican case, which is like 22 by 16 by 16. So they want everything to fit in the one case. Well, we're going to have, there's no chair associated with you. You have to sit in your own chair. So it'll be like a steering wheel, the levers that you need, mixed reality, and a couple other things. And it's got to all fit in the damn case. So there's no room. But there's all different kinds of motion. Some of the big flight simulators, they're called level D, and they're actually like $20 million. And you need to have a 30-foot concrete floor in them. They're enormous. They're like 20 feet above the ground. And the kinds of simulator I built is what we call a lightweight simulator, which is a fraction of the price and something that the Air Force wants to go because they can buy 30 of mine for the cost of a level D simulator. And that's one of the things they use lightweight to be both things, light in weight and light in cost. Mine runs a 120. It gets, it can just go and sit. It's actually in Barksdale Air Force Base right now in one of the rooms being used by the pilots. And it's big and bulky. And if I build it again, I change the green screen because it's hard to maneuver. But it's really not that big, relatively speaking. And it's really not that, in Air Force dollars, it's really not that much. It's a whole other kind of dollars. Yes.
Follow up to the entrepreneur question. We saw your slide in 2019, all the projects that you worked on. How did you get all those projects?
One of the things I say to people when they go into a new market, which is what I did, was you basically have to soak it up completely. And I would do, and I kind of hit it right a little bit before COVID. But once COVID hit, I ain't going anywhere. So, I'm in every webinar. I'm in LinkedIn. I have 2,400 contacts on LinkedIn. I connect with everybody. And once or twice a week, I speak to somebody about a new technology or a new way of getting into it. And I just immersed myself in that industry. It has its own language, and specifically, each of the services is different. So I'm in the Air Force. It's hard for me to learn the Army. It's hard for me to learn the Navy. But in each of those cases, I just do every event. I do every event. I speak to everybody I know and understand how it works to get in the doors. And many, many large companies have small business doors, and they have departments devoted to working with small businesses. And you need to learn where they are. They encourage you to be there. They, besides being good citizens, they want to take advantage of your work. They want to, the bigs, we call the bigs, the Lockheeds, the Boeings, the Northrops. They're the bigs, and they want you to subcontract them for them because they can get you cheap. They can still put their markup on top of you, and they'll be happy, and we would be happy just, giving them our regular prices. Yeah. Raj, you first. You're closer.
Given what you have seen so far,
Mm-hmm.
in the next 20, 30 years, how do you think from your perspective, our personal lives and work lives would change? I don't know how many use cases will be there in so many industries with this technology.
How many use cases will be there? Or just,
No,
yeah. I mean, it's unlimited.
How would it impact our personal lives and work lives? How do you think it would?
Well, with all the changes we see all the time, from the industrial age back, people still work, jobs change. As I say that if we're using AI generated content, it's not going to, there aren't still going to be people there that work with those content machines. And so I think that there'll still be jobs for everybody, but they're going to be different kinds of jobs. I mean, as far as use cases for what VR, AR, and mixed reality can be, anything that you need to learn, certainly anything that you're doing hands-on can be done inside of those environments, and they can be done in your home. You can do them anywhere. And that was some of the pitches we made for the network training next, is you can do it from anywhere. And they talk about that a lot in the military, about wanting them to be able to train at need, at their location of choice. And so, we're giving them, and also they find that today's students are trained, they're digital first people. And digital first people do not want to be looking at PDFs. They don't want to be reading books, and they don't want to be listening to lectures. They want to do it the other way. They want to do it in the world they're used to. Okay. Yes.
Yes, sure. As much as you've seen technology grow, over the past years, and even with the budget that you've done, I mean, what is your goal?
What is my goal?
Yeah, like, what's your
I just I have insatiable curiosity. And so with that being said, if I see a project that's coming by that has 50% of what I understand, I'm going for it, because I'll learn that other 50% in the process. And I love training because I love seeing how it benefits people. And so it's really kind of associated in that area. But now, I mean, this railway thing that we're talking about right now, that's like a game changer. I mean, that's a complete game changer. It's a 6-year project probably to get all the mapping done and everything else. And everything I build, I want to scale it. So I'm always looking for something to scale. If I could scale the B-52 simulator, which I've tried multiple times already, I'll scale it. It's a great way to make a living. Yes.
Just for this year, stating a similar project that had been done in Germany.
Excuse me? Did I? Yeah.
Similar project.
I haven't seen a digital twin set up here yet. I mean, I've seen lots of digital twins, but some of these cases are, you can't solve the problem until the technology arrives. The student doesn't show, what's the term? The student doesn't show up, the teacher doesn't show up until the student is ready. Well, the Germany project is a €6 billion project. Okay. It's money, but what they're doing is slightly different. They're looking at it not just from the training aspect that I look at it, is they're looking at it as automating their entire 33,000 kilometers of railway and 5,700 stations. So that's where they believe that they're going to pick up their capital expenditure to devote it to that. The UK, I mean, they're not thinking that same way. The Germans are very different in how they commit to projects like that. Do I think that if we can move forward with this project in the UK, do I think it's scalable and can move outside of the UK? Certainly.
Given the collisions, train wrecks.
Yeah, exactly. Exactly. And if they, the unions in the UK wouldn't be happy if I said we plan on replacing the drivers. But I think that the Germans actually are looking for an autonomous network completely through their country because of the efficiency. But you're totally right. I see what goes on here. And, once again, our rail system isn't, if you've driven on the trains in Europe, and it's a lot different than here. It really is. It's enjoyable. It's like the huge difference. Anything else? You guys are awesome tonight. Really appreciate you. Really appreciated you. Really great to have you. Thanks so much. Really appreciate it. Great.
Thank you so much, Neil. I appreciate.
Thank you
your
for inviting me.
I mean, I remember our conversation last fall, and I said, okay, let's try something new. So thank you for your willingness to partner with us. I am going to make a pitch for a survey that for those of you that are here virtually, there's a link